This is Ansh from SMU. This is the math and semester solution video number 2. We have this given integral whose limit is set to r, and r in the xy plane is given by these points. So just for our convenience, we'll get another two variables, namely u and v. You can name them whatever you want. And from the question, we will claim u to be y minus x and v to be y plus x. Now if you manipulate these two equations, we can also write u plus v by 2 as y and v minus u by 2 as x. You gotta add the equations once and subtract the equations once to get these two. Now we want to do this so that we can integrate this given integral in terms of u and v, and to do that we need to get to set the limits in terms of u and v. We need to get an integrating factor that's called a Jacobian. For now I am representing the Jacobian by j, so we'll still have this integral, but we can replace these values y minus x and y plus x by u and v, and the dA will turn into du dv when we'll see later. To convert u and v, to get the limits, first we need to get u and v in terms of x and y. So we'll plot x and y, u and v. So we have the given values in terms of x and y. To convert, to get the values in terms of u and v, we'll put these values in these equations. And we'll get the values as follows: minus 1 1, minus 2 2, minus 1 1, and 2 2. I've done this question twice or thrice now, so I have memorized the values, but you can do it on your own. Now we'll plot the graphs in terms of xy and uv to get the limits in terms of u and v. So first we'll plot the xy graph. We have the points 1 0, 2 0, 0 1, and 0 2. So we'll get this enclosed region. Now we can also plot the uv graph. We have the points minus 1 1, minus 2 2, 1 1, 2 2. So in terms of u and v, we get this trapezoid. Now from this graph we'll get the limits of v. We have its least limit as 1 and the highest limit as 2. So we can say it goes from 1 to 2, just for our sake. And we want to plot u in terms of v as in a variable form, so we'll go through the xy graph for that. We have this equation. This is the x-axis, which is y is equal to 0, and this equation too, which is the this is the y-axis, which is x is equal to 0. We can replace y and x with these values to get u in terms of v. So we get u plus v by 2 is equal to 0, which means u is equal to minus v, and from this equation we get v minus u by 2 is equal to 0, which is v is equal to u. So we get u's limit as minus v to v. Now we'll find the Jacobian. The Jacobian is nothing but the determinant of del xy by del uv, which can be expanded and written as del x by del u, del x by del v, del y by del u, del y by del v. So we get these values by partially differentiating these equations. I have memorized the values. They go as follows: 1 by 2, 1 by 2, 1 by 2, 1 by 2. You can do this if you want to, but I have memorized the values. So we get the value of the Jacobian as 1 by 2. So we calculated the Jacobian as half we have the limits in terms of we have the v limit as 1 to 2 and u limit as minus v to v. So we can change this integral here. So we have minus v to v and 1 to 2, and we have the integral cos uv times the Jacobian, which is half times du dv. First we are integrating in terms of u, so and v is considered as a constant, so it's a simple integration of cos u, which is nothing but sine u by v. Since v is a constant, we can multiply it here. We can take half outside since it's a universal constant times dv. This goes from minus v to v. So we get sine of 1 minus of sine of minus 1 times v and dv, which is nothing but twice of sine 1 times v dv. This is a simple integration of v, which we can take sine 1 outside. V becomes v square by 2. Its limits are 1 to 2. We get sine 1 times we get sine 1 by 2. Thank you. Sorry, I made a very silly mistake. The actual final answer is 3 times sine 1 by 2. It's an arithmetical mistake on my hand. I hope you all do well. Thank you.